Hi friends, myself Chandra Kumar. I am taking power electronics for the fifth semester electrical engineering students. In continuation of the previous lectures, we are discussing about the natural commutation and the first and last eight type post commutation. Now, in continuation of the commutation process, we move towards another type of method which we are using for the commutator of power electronic devices that will be considered as a class B type commutator. This is also known as a self-commutation circuit in which commutation of SCR is achieved automatically by the combination of L and C components. Once the SCR is turned on by using the filing circuit, in this the LC resonant circuit is connected across the SCR but not in series with load as in the case of class A combination, and hence the L and C components do not carry the load current. When the DC supply is applied to the circuit, the capacitor charges with an upper plate positive and lower plate negative up to the supply voltage E. When the SCR is triggered, the current flows in two directions. One is through E positive to SCR towards R towards E negative, and another one is the commutating current through L and C components. This will be the circuit diagram. Over here, you have to find out on this thing that there is a SCR, there is LC, and the RL circuit. So at the start, there is a flow of the supply through this side, and if the SCR is under the on state, then automatically the supply will be moving from the VDC positive towards the SCR, towards the IA, and then RL towards the minus VDC. And another circuit current which will be flowing through the positive LC RL and this, or a four a path will be formed in between of the LC and LC and the SCR. So whenever the capacitor is fully charged, there is a reverse polarity will be moving on this side, and the current is flowing LC and R. So more current will be flowing through the SCR while the capacitor is fully charged. So there is a pulses which will indicate over the gate. This first one is the gate pulse. Next one is the load in the inductive current that will be straightened at this moment whenever the supply is given and the SCR is conducting, then automatically the constant current will be going through this one, and after the capacitor is charged then a reverse current will be moving out, and the current it will increase the level of the current which is flowing through the inductance, so that then as the capacitor is fully charged then it will be declined towards the zero and then make a straight line. Similarly, the current through the SCR, we are finding that at that moment, whenever the supply is moving on and the L and C are connected in parallel with the SCR, we are finding that the waveform of the towards the SCR current, it will be close to the sinusoidal one, and it will be moving up to the point where until or unless we are achieving the maximum value of the inductance. Similarly, whenever we have to just focus over the capacitor, over the voltage across the SCR, we are finding that the initial point whenever the SCR is conducting and the current is going through the SCR, we are not getting any kind of waveform across the SCR, and some voltage we are getting in the negative half because the current ticks their on is there in the negative, move towards the negative side, so the voltage is moving over this side, and then it will be turn off this will be the stage of the turn off of your SCR, and then will maintain a constant value because at that moment there is no current will be flowing through the SCR. So we are observing the voltage across the SCR at that moment. Once the SCR is turned on, the capacitor starts discharging through C positive, L, E, and C. When the capacitor is fully discharged, it starts charging with a reverse polarity, hence a reverse voltage applied across the SCR which causes the commutating current IC to oppose load current IA. When the commutating current IC is higher than the load current, the SCR will automatically turn off and the capacitor charges with original polarity. In the above process, the SCR is turned on for some time and then automatically turned off for some time. This is a continuous process, and the desired frequency of on-off depends on the values of L and C. This type of computation is mostly used in the chopper circuit. Next will be the class C type commutation. In this commutation method, the main SCR is to be commutated. It's connected in series with the load and an additional or complementary SCR. It's connected in parallel with main SCR. This method is also called as complementary commutation. In this, SCR turns off with a reverse voltage of a charged capacitor. The figure shows the complementary commutation with appropriate waveform. Initially, both SCRs are in off state, so the capacitor voltage is also zero. When the SCR1 or main SCR is triggered, current starts flowing in two directions. One path is P positive to R1 to SCR1 to E negative, and the another path is the charging current. It will flow from the E positive to R2 plus to C plus to C minus to SCR1 and then E. Therefore, the capacitor starts charging up to the value of E. This will be the circuit diagram of the circuit diagram with their waveform. Over here, this will be working as a complementary to each other. If we are saying that the SCR1 is the main one and SCR2 will be the auxiliary one. So whenever the capacitor is charged, the entire voltage which will be given from this side, it will be moving from the RL towards this side, and some current will be flowing through the R. So combine of current that will be flowing to the SCR1 at that moment. Whenever the capacitor is fully charged, then it will oppose the supply. So automatically the direction of the current it will changes from the SCR1 towards the SCR2, and at that moment whenever the SCR2 is turned on, then automatically the supply will be moving from the RLC towards the SCR2 and complete their path with the help of the battery. So there is a two gate first we are using gate 1 and gate 2. And the current which will be flowing to the R1, it will be indicated over this side that it will be flowing in a straight line while the SCR1 is conducting, and suddenly there is a rise in the current because due to the it will be rises due to the capacitor which will be placed over here, it will change their polarity, and suddenly a voltage will be the current IR1 will be increases and suddenly and then it will goes to the towards the zero, and the same process will be going on. Similarly, in case of the SCR, the change in current with respect to time it will change it because at the start SCR over here we are just focusing on the SCR1. So at that moment a high current will be flowing, then it will maintain a constant one and then it will become the zero because the voltage which we are getting will be the EDC dividing by RL. So that will be the waveform over this side. And similarly for the ET2, we are getting that their voltage across the diaster one. If we are getting, it will be the same process as in the previous cases. The voltage will be rising low and then it will be moving on the upward side. When the SCR2 is triggered, SCR is turned on, and simultaneously a negative polarity is applied across the SCR1. So this reverse voltage across the SCR1 immediately causes to turn off the SCR1. Now the capacitor starts charging with a reverse polarity through the path of E positive, R1, C positive, C minus, or SCR2 and E negative. And again, if the SCR1 is triggered, the discharging current of the capacitor turns off the SCR2. This commutation is mainly used in single phase inverters with a central tap transformer. The McMurray backforward inverter is the best example of this commutation circuit. This is a very reliable method of commutation and it is also useful even at frequencies below 1000 Hz. Next will be the class D commutation. This is also called as auxiliary commutation because it uses an auxiliary SCR to switch the charged capacitor. In this, the main SCR is commutated by the auxiliary circuit. The main SCR with low resistance forms the power circuit, while the diode D, inductor L, and SCR2 form the commutation circuit for the system. When the supply voltage E is applied, both SCRs in off state and hence the capacitor voltage is zero. In order to charge the capacitor, SCR2 must be triggered first, so the capacitor charges through the path E positive, C positive, C negative, SCR2, R, and then E negative. When the capacitor is fully charged, the SCR2 becomes turned off because no current flows through the SCR2 when capacitor is charged fully. If the SCR1 is triggered, the current flows into the axle. One is the load current path this, and the another one is the commutation current path C polarity, SCR1 LDC. As soon as the capacitor completely discharges, its polarity will be reversed, but due to the presence of diode, the reverse discharge is not possible. When the SCR2 is triggered, capacitor starts discharging through the C positive, SCR2, SCR1, C negative. When this discharge current is more than the load current, the SCR1 becomes turned off. Again, the capacitor starts charging through the SCR2 to a supply voltage E, and then the SCR2 is turned off. Therefore, both SCRs are turned off and the above cyclic process is repeated. This commutation method is mainly used in inverters and also used in the Jones-Chopper circuit. Next will be the class E type commutation. This is also known as external pulse commutation. In this, an external pulse source is used to produce the reverse voltage across the SCR, the circuit below. Shows the class E commutation circuit which uses a pulse transformer to produce the commutating pulse and is designed with tight coupling between the primary and secondary with a small air gap. If the SCR need to be commutated, pulse duration equal to the turn of time of the SCR is applied. When the SCR is triggered, load current flows through the pulse transformer. If the pulse is applied to the primary of the pulse transformer, and EMF or voltage is induced in the secondary of the pulse transformer. This is the circuit diagram of the class E type commutation where the VDC will be the supply voltage, one capacitor is connected in parallel with the SCR, there is a pulse transformers are there, so the pulse generator is generate a pulse and it will give you the signal towards this side and the IL will run to the RF. So we are getting the gate pulse will be given, then we are measuring the voltage across the resistor one, then there is a potential across the pulse transformer, and last one will be the current through the resistor in the respect of the di by dt. This induced voltage is applied across the SCR as a reverse polarity and hence the SCR is turned off. The capacitor offers a very low or zero impedance to the high frequency pulses. Thank you for attending the lectures on the commutation. This will be the end of the commutation part of SCR. Thank you.